Standard 5, Mathematics, Chapter number 5, Fractions. Hello students! Today we will learn the 5th chapter of Mathematics. The name of this chapter is Fraction. Equivalent fractions. If one bhakri is divided equally between two people, each one will get half a bhakri. The fraction half is written as 1 upon 2. Here, 1 is the numerator and 2 is the denominator. This 2 means that half a bhakri was given. 6 equal parts were made of one melon. They were shared equally by 2 people. It means that the part that each one got was 3 upon 6. Each one actually got half the melon. Thus, 3 upon 6 also shows the fraction 1/2. In the 3 examples above, the fraction half has been shown by 1 upon 2, 2 upon 4, 3 upon 6 respectively. It means that the value of 1 upon 2, 2 upon 4, 3 upon 6, these all 3 fractions is the same. This is written as 1 upon 2 is equal to 2 upon 4 is equal to 3 upon 6. Such fractions of equal value are called equivalent fractions. Look at the colored parts of the 2 equal circles shown alongside. One circle is divided into 3 equal parts and 2 of them are colored. That is, the colored part is 2 upon 3 of the circle. The other circle of the same size is divided into 6 equal parts and 4 of them are colored. That is, 4 upon 6 of the whole circle is colored. However, we see that the colored parts of the 2 circles are equal. Therefore, 2 upon 3 is equal to 4 upon 6. Thus, 2 upon 3 and 4 upon 6 are equivalent fractions. Obtaining equivalent fractions. 2 of the 5 equal parts in the figure are colored. The colored part is 2 upon 5 of the whole figure. When 2 lines are drawn across the same figure, it gets divided into 15 equal parts. So, now the fraction that shows the colored part is 6 upon 15. However, the colored part has not changed. Therefore, we see that 2 upon 5 is equal to 6 upon 15. Do you see any special connection between the numerators and denominators of the fractions 2 upon 5 and 6 upon 15?
3 times 2 is 6 and 3 times 5 is 15.
We have also seen that 1 upon 2 is equal to 2 upon 4, 1 upon 2 is equal to 3 upon 6 and 2 upon 3 is equal to 4 upon 6. In 2 equivalent fractions, the numerator of one fraction is as many times the numerator of the other as the denominator of one is of the denominator of the other. When the numerator and denominator of a fraction are multiplied by the same non-zero number, we get a fraction that is equivalent to the given fraction.
Can I get an equivalent fraction by dividing the numerator and denominator by the same number?
Of course! If the numerator and denominator have a common divisor, then the fraction obtained on actually dividing them by that divisor is equivalent to the given fraction. The numerator and denominator of the fraction 6 upon 15 can be divided by 3. On doing this division, we get the fraction 2 upon 5. It means that 6 upon 15 is equal to 2 upon 5. If the numerator and denominator have a common divisor, then the fraction we get on dividing them by that divisor is equivalent to the given fraction. Divide the numerator and denominator of 6 upon 12 by the same number to find an equivalent fraction.
Sonu obtained this fraction.
6 upon 12 is equal to 6 divided by 2 upon 12 divided by 2, which is equal to 3 upon 6.
Meenu obtained this fraction.
6 upon 12 is equal to 6 divided by 3 upon 12 divided by 3, which is equal to 2 upon 4.
6 and 12 can also be divided by 6. Will that do?
Sure. 6 upon 12 is equal to 6 divided by 6 upon 12 divided by 6, which is equal to 1 upon 2. Remember that the fractions we get by dividing 6 upon 12 by 2 or 3 or 6 are all equivalent to 6 upon 12. That is, 6 upon 12 is equal to 3 upon 6, which is equal to 2 upon 4, which is equal to 1 upon 2. Example 1. Find a fraction with denominator 30, which is equivalent to 5 upon 6. 5 upon 6 is equal to empty box upon 30. We must find the right number for the box. Here, 5 times the denominator 6 is 30. What is 5 times the numerator 5? 5 upon 6 is equal to 5 multiplied by 5 upon 6 multiplied by 5, which is equal to 25 upon 30. Hence, the fraction 25 upon 30 with denominator 30 is equivalent to 5 upon 6. Example 2. Find a fraction equivalent to 15 upon 40 but with denominator 8. 15 upon 40 is equal to empty box upon 8. We must find the number for the box. 40 divided by 5 is 8. So, we will get the number for the box by dividing 15 by 5. 15 divided by 5 is equal to 3. Therefore, 15 upon 40 is equal to 3 upon 8. Thus, the fraction 3 upon 8 is equivalent to the fraction 15 upon 40. Dear students, now we will solve the problem set 17. 1. Write the proper number in the box. 1 upon 2 is equal to empty box upon 20. The product of 10 multiplied by 2 is 20. Therefore, by multiplying 10 by 1, we get the number which will be in the box. Therefore, the number in the box is 1 multiplied by 10 is equal to 10. 2. 3 upon 4 is equal to 15 upon empty box. The product of 5 multiplied by 3 is 15. Therefore, by multiplying 5 by 4, we get the number which will be in the box. Therefore, the number in the box is 5 multiplied by 4 is equal to 20. Here, I have solved 2 sub-questions of problem number 1 as an example. Now, you have to solve the remaining sub-questions. Now, we will solve second problem of problem set 17. 2. Find an equivalent fraction with denominator 18 for each of the following fractions. 1 upon 2, 2 upon 3, 4 upon 6, 2 upon 9, 7 upon 9, 5 upon 3. Answer. We know that when the numerator and denominator of a fraction are multiplied by the same non-zero number, we get a fraction that is equivalent to the given fraction. Therefore, we should multiply numerator and denominator of 1 upon 2 by 9. Hence, 1 multiplied by 9 upon 2 multiplied by 9 is equal to 9 upon 18. We should multiply numerator and denominator of 2 upon 3 by 6. Hence, 2 multiplied by 6 upon 3 multiplied by 6 is equal to 12 upon 18. We should multiply numerator and denominator of 4 upon 6 by 3. Hence, 4 multiplied by 3 upon 6 multiplied by 3 is equal to 12 upon 18. We should multiply the numerator and denominator of 2 upon 9 by 2. Hence, 2 multiplied by 2 upon 9 multiplied by 2 is equal to 4 upon 18. We should multiply the numerator and denominator of 7 upon 9 by 2. Hence, 7 multiplied by 2 upon 9 multiplied by 2 is equal to 14 upon 18. we should multiply the numerator and denominator of 5 upon 3 by 6. Hence, 5 multiplied by 6 upon 3 multiplied by 6 is equal to 30 upon 18. Now, we will solve the third problem of problem set 17. 3. Find an equivalent fraction with denominator 5 for each of the following fractions: 6 upon 15, 10 upon 25, 12 upon 30, 6 upon 10, 21 upon 35. Answer: we know that if the numerator and denominator have a common divisor, then the fraction we get on dividing them by that divisor is equivalent to the given fraction. We should divide the numerator and denominator of 6 upon 15 with 3. Hence, 6 divided by 3 upon 15 divided by 3 is equal to 2 upon 5. We should divide the numerator and denominator of 10 upon 25 with 5. Hence, 10 divided by 5 upon 25 divided by 5 is equal to 2 upon 5. We should divide the numerator and denominator of 12 upon 30 with 6. Hence, 12 divided by 6 upon 30 divided by 6 is equal to 2 upon 5. We should divide the numerator and denominator of 6 upon 10 with 2. Hence, 6 divided by 2 upon 10 divided by 2 is equal to 3 upon 5. We should divide the numerator and denominator of 21 upon 35 with 7. Hence, 21 divided by 7 upon 35 divided by 7 is equal to 3 upon 5. Dear students, I have solved here problem number 1, 2 and 3 as an example. Now, you have to solve the remaining problems, that means problem number 4 and 5. Like fractions and unlike fractions. Fractions such as 1 upon 7, 4 upon 7, 6 upon 7, whose denominators are equal, are called like fractions. Fractions such as 1 upon 3, 4 upon 8, 9 upon 11, which have different denominators, are called unlike fractions. Converting unlike fractions into like fractions. Example 1. Convert 5 upon 6 and 7 upon 9 into like fractions. Here, we must find a common multiple for the numbers 6 and 9. Multiples of 6 are 6, 12, 18, 24, 30, 36 and so on. Multiples of 9 are 9, 18, 27, 36, 45 and so on. Here, the number 18 is a multiple of both 6 and 9. So, let us make 18 the denominator of both the fractions. 5 upon 6 is equal to 5 multiplied by 3 upon 6 multiplied by 3, which is equal to 15 upon 18. 7 upon 9 is equal to 7 multiplied by 2 upon 9 multiplied by 2, which is equal to 14 upon 18. Thus, 15 upon 18 and 14 upon 18 are like fractions, respectively, equivalent to 5 upon 6 and 7 upon 9. Here, 18 is a multiple of both 6 and 9. We could also choose numbers like 36 and 54 as the common denominators. Example 2. Convert 4 upon 8 and 5 upon 16 into like fractions. As 16 is twice 8, it is easy to make 16 the common denominator. 4 upon 8 is equal to 4 multiplied by 2 upon 8 multiplied by 2, which is equal to 8 upon 16. 8 upon 16 thus, 8 upon 16 and 5 upon 16 are the required like fractions. Example 3. Find a common denominator for 4 upon 7 and 3 upon 4. The number 28 is a multiple of both 7 and 4. So, make 28 the common denominator. 4 upon 7 is equal to 4 multiplied by 4 upon 7 multiplied by 4, which is equal to 16 upon 28. 3 upon 4 is equal to 3 multiplied by 7 upon 4 multiplied by 7, which is equal to 21 upon 28. Therefore, 16 upon 28 and 21 upon 28 are the required like fractions. Now, we will solve the problem set 18. Convert the given fractions into like fractions. 1. 3 upon 4, 5 upon 8. Answer. As 8 is twice of 4 here, it is easy to make 8 as the common denominator. 3 upon 4 is equal to 3 multiplied by 2 upon 4 multiplied by 2, which is equal to 6 upon 8. 6 upon 8 and 5 upon 8 are like fractions. 2. 3 upon 5, 3 upon 7. Answer. Here, the number 35 is a multiple of both 5 and 7. So, let us make 35 the denominator of both fractions. 3 upon 5 is equal to 3 multiplied by 7 upon 5 multiplied by 7, which is equal to 21 upon 35. 3 upon 7 is equal to 3 multiplied by 5 upon 7 multiplied by 5, which is equal to 15 upon 35. Therefore, 21 upon 35 and 15 upon 35 are like fractions. Here, I have solved two problems as an example. Now students, you have to solve the remaining problems. Comparing like fractions. Example 1. A strip was divided into 5 equal parts. It means that each part is 1 upon 5. Colored part is 3 upon 5, which is equal to 1 upon 5 plus 1 upon 5 plus 1 upon 5. The white part is 2 upon 5, which is equal to 1 upon 5 plus 1 upon 5. The colored part is bigger than the white part. This tells us that 3 upon 5 is greater than 2 upon 5. This is written as 3 upon 5 is greater than 2 upon 5. Example 2. This strip is divided into 8 equal parts. 3 of the parts have one color and 4 have another color. Here, 3 upon 8 is lesser than 4 upon 8. In like fractions, the fraction with the greater numerator is the greater fraction. Comparing fractions with equal numerators. You have learned that the value of fractions with numerator 1 decreases as the denominator increases. Even if the numerator is not 1, the same rule applies so long as all the fractions have a common numerator. For example, look at the figures below. All the strips in the figure are alike. 2 of the 3 equal parts of the strip, 2 upon 3. 2 of the 4 equal parts of the strip, 2 upon 4. 2 of the 5 equal parts of the strip, 2 upon 5. The figure shows that 2 upon 3 is greater than 2 upon 4, which is greater than 2 upon 5. Of two fractions with equal numerators, the fraction with the greater denominator is the smaller fraction. Comparing unlike fractions. Suppose we have to compare the unlike fractions 3 upon 5 and 4 upon 7. Let us take an example to see how this is done. These two boys are standing on 2 blocks. How do we decide who is taller?
But the height of the blocks is not the same. If both blocks are of the same height, it is easy to tell who is taller.
Now that they are on blocks of equal height, we see that the boy on the right is taller.
The height of the boys can be compared when they stand at the same height. Similarly, if fractions have the same denominators, their numerators decide which fraction is bigger.
Got it. Let's obtain the same denominators for both fractions.
5 into 7 can be divided by both 5 and 7. So, 35 can be the common denominator. 3 upon 5 is equal to 3 multiplied by 7 upon 5 multiplied by 7, which is equal to 21 upon 35. 4 upon 7 is equal to 4 multiplied by 5 upon 7 multiplied by 5, which is equal to 20 upon 35. 21 upon 35 is greater than 20 upon 35. Therefore, 3 upon 5 is greater than 4 upon 7.
To compare unlike fractions, we convert them into their equivalent fractions so that their denominators are the same. Problem set 19. Write the proper symbol from lesser than, greater than or equal to in the box. 1. 3 upon 7 is equal to 3 upon 7. 2. 3 upon 8 is greater than 2 upon 8. 3. 2 upon 11 is lesser than 10 upon 11. I have solved here 3 problems as an example. Now, you have to solve the remaining problems. Addition of like fractions. Example 1. 3 upon 7 plus 2 upon 7 is equal to how much? Let us divide a strip into 7 equal parts. We shall color 3 parts with one color and 2 parts with another. The part with one color is 3 upon 7 and that with the other color is 2 upon 7. The total colored part is shown by the fraction 5 upon 7. It means that 3 upon 7 plus 2 upon 7 is equal to 3 plus 2 upon 7, which is equal to 5 upon 7. Example 2. Add 3 upon 8 plus 2 upon 8 plus 1 upon 8. The total colored part is 3 upon 8 plus 2 upon 8 plus 1 upon 8, which is equal to 3 plus 2 plus 1 upon 8, which is equal to 6 upon 8. When adding like fractions, we add the numerators of the 2 fractions and write the denominator as it is. Example 3. Add 2 upon 6 plus 4 upon 6. 2 upon 6 plus 4 upon 6 is equal to 2 plus 4 upon 6, which is equal to 6 upon 6. However, we know that 6 upon 6 means that all 6 of the 6 equal parts are taken. That is, one whole figure is taken. Therefore, 6 upon 6 is equal to 1. Note that if the numerator and denominator of a fraction are equal, the fraction is equal to 1. That is why 7 upon 7 is equal to 1, 10 upon 10 is equal to 1, 2 upon 5 plus 3 upon 5 is equal to 2 plus 3 upon 5, which is equal to 5 upon 5, which is equal to 1. Remember that if we do not divide a figure into parts but keep it whole, it can also be written as 1. This tells us that 1 is equal to 1 upon 1, which is equal to 2 upon 2, which is equal to 3 upon 3, and so on. You also know that if the numerator and denominator of a fraction have a common divisor, then the fraction obtained by dividing them by that divisor is equivalent to the given fraction. Therefore, 5 upon 5 is equal to 5 divided by 5 upon 5 divided by 5, which is equal to 1 upon 1, which is equal to 1. Dear students, now we will solve the problem set 20. So, let's solve the first problem. 1. Add 1. 1 upon 5 plus 3 upon 5 is equal to 1 plus 3 upon 5, which is equal to 4 upon 5. 2. 2 upon 7 plus 4 upon 7 is equal to 2 plus 4 upon 7, which is equal to 6 upon 7. Here, I have solved 2 sub-questions of the first problem as an example. Now, you have to solve the remaining sub-questions. Dear students, now we will solve the second question of problem set 20. 2. Mother gave 3/8 of one guava to Meena and 2/8 of the guava to Geeta. What part of the guava did she give them altogether? Answer. Here, we should add these two fractions. Therefore, 3/8 plus 2/8 is equal to 3 plus 2/8, which is equal to 5/8. Hence, mother gave them 5/8 part of the guava altogether. Now, students, you have to solve the remaining questions of this problem set. Subtraction of like problems. A figure is divided into 5 equal parts and 4 of them are colored. That is, 4/5 part of the figure is colored. Now, we remove the color from one of the colored parts. That is, we subtract 4/5 from 1/5. The remaining colored part is 3/5. Therefore, 4/5 minus 1/5 is equal to 4 minus 1/5, which is equal to 3/5. When subtracting a fraction from another like fraction, we write the difference between the numerators in the numerator and the common denominator in the denominator. Example 1. Subtract 7/13 minus 5/13. These two fractions have a common denominator. So, we shall subtract the second numerator from the first and write the denominator as it is. 7/13 minus 5/13 is equal to 7 minus 5/13, which is equal to 2/13. Example 2. If Raju got 5/12 part of a sugarcane and Sanju got 3/12 part, how much was the extra part that Raju got? To find out the difference, we must subtract. 5/12 minus 3/12 is equal to 5 minus 3/12, which is equal to 2/12. Thus, Raju got 2/12 extra. Dear students, now we will solve the problem set 21. So, let's solve the first example. 1. Subtract. 1. 5/7 minus 1/7 is equal to 5 minus 1/7, which is equal to 4/7. 2. 5/8 minus 3/8 is equal to 5 minus 3/8, which is equal to 2/8. Here, I have solved two sub-questions. Now, you have to solve the remaining sub-questions. Now, we will solve the second question of problem set 21. 2. 7/10 of a wall is to be painted. Ramu has painted 4/10 of it. How much more needs to be painted? Answer. Here we subtract 4/10 from 7/10. Therefore, 7/10 minus 4/10 is equal to 7 minus 4/10, which is equal to 3/10. Therefore, 3/10 part remains unpainted. Addition and subtraction of unlike fractions. Example 1. Add 2/3 plus 1/6. First, let us show the fraction 2/3 by coloring two of the three equal parts on a strip. You have learned to add and to subtract fractions with common denominators. Here, we have to add the fraction 1/6 to the fraction 2/3. So, let us divide each part on this strip into two equal parts. 4/6 is a fraction equivalent to 2/3. Now, as 1/6 is to be added to 2/3, that is, to 4/5, we shall color one more of the 6 parts on the strip. Now, the total colored part is 5/6. Therefore, 4/6 plus 1/6 is equal to 4 plus 1/6, which is equal to 5/6. That is, 2/3 plus 1 upon 6 is equal to 5 upon 6. Example 2. Add 1 upon 2 plus 2 upon 5. Here, the smallest common multiple of the two denominators is 10. So, we shall change the denominator of both fractions to 10. 1 upon 2 plus 2 upon 5 is equal to 1 multiplied by 5 upon 2 multiplied by 5 plus 2 multiplied by 2 upon 5 multiplied by 2, which is equal to 5 upon 10 plus 4 upon 10, which is equal to 5 plus 4 upon 10, which is equal to 9 upon 10. Example 3. Add 3 upon 8 plus 1 upon 16. Here, 16 is twice 8. So, we shall change the denominator of both fractions to 16. 3 upon 6 plus 1 upon 16 is equal to 3 multiplied by 2 upon 8 multiplied by 2 plus 1 upon 16, which is equal to 6 upon 16 plus 1 upon 16, which is equal to 6 plus 1 upon 16, which is equal to 7 upon 16. Example 4. Subtract 3 upon 4 minus 5 upon 8. Let us make 8 the common denominator of the given fractions. 3 upon 5 minus 5 upon 8 is equal to 3 multiplied by 2 upon 4 multiplied by 2 minus 5 upon 8, which is equal to 6 upon 8 minus 5 upon 8, which is equal to 6 minus 5 upon 8, which is equal to 1 upon 8. Example 5. Subtract 4 upon 5 minus 2 upon 3. The smallest common multiple of the denominators is 15. So, we shall change the denominator of both fractions to 15. 4 upon 5 minus 2 upon 3 is equal to 4 multiplied by 3 upon 5 multiplied by 3 minus 2 multiplied by 5 upon 3 multiplied by 5, which is equal to 12 upon 15 minus 10 upon 15, which is equal to 12 minus 10 upon 15, which is equal to 2 upon 15. Dear students, now we will solve the problem set 22. So, let's solve the first problem. 1. Add 1. 1 upon 8 plus 3 upon 4. Answer. Here, 8 is twice of 4. So, we will make the denominator of both fractions as 8. 1 upon 8 plus 3 upon 4 is equal to 1 upon 8 plus 3 multiplied by 2 upon 4 multiplied by 2, which is equal to 1 upon 8 plus 6 upon 8, which is equal to 1 plus 6 upon 8, which is equal to 7 upon 8. 2. 2 upon 21 plus 3 upon 7. Answer. Here, 21 is thrice of 7. Hence, we shall make the denominator of both fractions as 21. 2 upon 21 plus 3 upon 7 is equal to 2 upon 21 plus 3 multiplied by 3 upon 7 multiplied by 3, which is equal to 2 upon 21 plus 9 upon 21, which is equal to 2 plus 9 upon 21, which is equal to 11 upon 21. Here, I have solved 2 sub-questions of the first question. Now, you have to solve the remaining sub-questions. Dear students, now we will solve the second question of the problem set 22. 2. Subtract 1. 3 upon 10 minus 1 upon 20. Answer. Let us make 20 as the common denominator of both the fractions. 3 upon 10 minus 1 upon 20 is equal to 3 multiplied by 2 upon 10 multiplied by 2 minus 1 upon 20, which is equal to 6 upon 20 minus 1 upon 20, which is equal to 6 minus 1 upon 20, which is equal to 5 upon 20. 5. 2 upon 7 minus 1 upon 4. Answer: 28 is the smallest common multiple of the denominators. Therefore, we shall change the denominator of both fractions to 28. 2 upon 7 minus 1 upon 4 is equal to 2 multiplied by 4 upon 7 multiplied by 4 minus 1 multiplied by 7 upon 4 multiplied by 7, which is equal to 8 upon 28 minus 7 upon 28, which is equal to 8 minus 7 upon 28, which is equal to 1 upon 28. Dear students, I have solved here 2 sub-questions of the second problem. Now, you have to solve the remaining sub-questions. A fraction of a collection and a multiple of a fraction. 1 upon 4 of a collection of 20 dots. 1 upon 4 is equal to 5 of 20. 20 divided by 4 is equal to 5. 1 upon 2 of a collection of 20 dots, 20. 1 upon 2 of 20 means 10. 20 divided by 2 is equal to 10. 3 upon 4 of a collection of 20 dots. 3 upon 4 is equal to 1 upon 4 plus 1 upon 4 plus 1 upon 4. 3 upon 4 of 20 is 3 1 upon 4 parts of 20, that is 15 dots. 20 divided by 4 is equal to 5. 5 multiplied by 3 is equal to 15. Twice 5 is 10. 2 rolls of 5 balls each. 5 multiplied by 2 is equal to 10. Twice 5 is 10. 1 upon 2 times 10. 1 upon 2 of 10 is equal to 5. 1 upon 2 times 10 is equal to 5. Thrice 5. Total balls 15. Thrice 5 is equal to 15. That is, 5 multiplied by 3 is equal to 15. 1 upon 3 times 15. Hence, 15 multiplied by 1 upon 3 is equal to 5. 15 divided by 3 is equal to 5. 2 upon 3 times 15. To get 2 upon 3 times 15 is to find 1 upon 3 times 15 and take it twice. Meena has 5 rupees. Tina has twice as many rupees. That is, Tina has 5 multiplied by 2 is equal to 10 rupees. Meena has half as many rupees as Tina. That is, 1 upon 2 of 10 or 5 rupees. Ramu has to travel a distance of 20 kilometers. If he has travelled 4 upon 5 of the distance by car, how many kilometers did he travel by car? 4 upon 5 of 20 kilometers is 20 multiplied by 4 upon 5. So, we take 1 upon 5 of 20 4 times. 1 upon 5 of 20 is equal to 4. 4 times 4 is 4 multiplied by 4, which is equal to 16. It means that 20 multiplied by 4 upon 5 is equal to 16. Ramu travelled a distance of 16 kilometers by car. Dear students, now we will solve the first example of problem set 23. 1. What is 1 upon 3 of each of the collections given below? 1. 15 pencils. Answer: 1 upon 3 of 15 means 15 multiplied by 1 upon 3, which is equal to 5. 15 divided by 3, which is equal to 5. Therefore, 1 upon 3 pencils mean 5 pencils. Students, I have solved here the first sub-questions of the first problem as an example. Now, you have to solve the remaining sub-questions. Students, let's solve the second problem of problem set 23. 2. What is 1 upon 5 of each of the following? 1. 20 rupees. Answer: 1 upon 5 of 20, it means 20 multiplied by 1 upon 5, which is equal to 4. 20 divided by 5 is equal to 4. Therefore, 1 upon 5 of 20, it means 4 rupees. Students, I have solved here the first sub-question of the second problem as an example. Now, you have to solve the remaining sub-questions. Dear students, now we will solve the third problem of problem set 23. 3. Find the part of each of the following numbers equal to the given fraction. 1. 2 upon 3 of 30. Answer. Making 2 upon 3 of 30 means making twice 1 upon 3 of 30. Therefore, 30 multiplied by 1 upon 3 is equal to 10. 30 divided by 3 is equal to 10. 10 multiplied by 2 is equal to 20. Therefore, 2 upon 3 of 30, it means 20. Students, I have solved here the first sub-question of the third problem as an example. Now, you have to solve the remaining sub-questions. Mixed fractions. Half of each of the 3 circles is colored. That is, 3 parts, each equal to 1 upon 2 of the circle are colored. The colored part is 1 upon 2 plus 1 upon 2 plus 1 upon 2, that is 1, 1 upon 2 or 3 upon 2. 1 upon 2 is written as 1 upon 2. 1 upon 2 is read as 1 and 1 upon 2. In the fraction 1 and 1 upon 2, 1 is the integer part and 1 upon 2 is the fraction part. Hence, such fractions are called mixed fractions or mixed numbers. 3 upon 2, 5 upon 3 are improper fractions. We can convert improper fractions into mixed fractions. For example, 3 upon 2 is equal to 2 plus 1 upon 2, which is equal to 2 upon 2 plus 1 upon 2, which is equal to 1 plus 1 upon 2, which is equal to 1 and 1 upon 2. Activities. 1. Color the hats. In the picture alongside, color 1 upon 3 of the hats red. There is a total of 15 hats in the picture. Therefore, 1 upon 3, it means 1 upon 3 of 15. Therefore, 15 multiplied by 1 upon 3 is equal to 5. 15 divided by 3 is equal to 5. Therefore, we color the 5 hats with red color. Color 3 upon 5 of the hats blue. It means 3 upon 5 of 15. It means making 3 upon 5 of 15 and making thrice of it. 15 multiplied by 1 upon 5 is equal to 3. 15 divided by 5 is equal to 3. 3 multiplied by 3 is equal to 9. Therefore, we color 9 hats with blue color. How many hats have you colored red? Answer. We colored 5 hats with red color. How many hats have you colored blue? Answer. We colored 9 hats with blue color. How many are still not colored? Answer. 1 hat is still not colored. 2. Make a magic spinner. Take a white cardboard disc, as shown in the figure, divide it into 6 equal parts. Color the parts red, orange, yellow, green, blue and violet. Make a small hole at the center of the disc and fix a pointed stick in the hole. Your magic spinner is ready. What fraction of the disc is each of the colored parts? Answer. The disc is divided into 6 equal parts. Therefore, the colored part of the disc is 1 upon 6. Give the disc a strong tug to make it turn fast. What color does it appear to be now? Answer. White color appears when the disc turns fast.
The clever poet. There was a king who had a great love for literature. A certain poet knew that if the king read a good poem, it made him very happy. Then the king would give the poet an award. Once the poet composed a good poem. He thought if he showed it to the king, he would win a prize. So he went to the king's palace. But it was not easy to meet the king. You had to pass a number of gates and guards. The first guard asked the poet why he wanted to meet the king. So, the poet told him the reason. Seeing the chance of getting a share of the award, the guard demanded, "You must give me 1/10 of your prize. Only then will I let you go in." The poet could do nothing but agree. The second guard stopped him and said, "I will let you go in only if you promise me 2/5 of your prize." The third guard too was a greedy man. He said, "I will not let you go unless you promise me 1/4 of your prize." The king's palace was just a little distance away. Now, the poet told the guard, "Why only 1/4? I shall give you half the price." The guard was pleased and let him in. The king liked the poem. He asked the poet, "What is the price you want?" "I shall be happy if your majesty awards me 100 lashes of the whip." The king was surprised. "Are you out of your mind?" he exclaimed. "I have never met anyone so crazy as to ask for a whipping." "Your Majesty, if you wish to know the reason, the 3 palace guards must be called here." When the guards came, the poet explained, "Your Majesty, all of them have a share in the 100 lashes that you have awarded to me. Each of them has fixed his own share of the prize I get. The first guard must get 1/10 of the award, that is 10 lashes. The second must get 2/5, which is 40, and the third must get half the award, that is 50 lashes. The king could now see how greedy the guards were and how clever the poet was. He saw to it that each guard got the punishment he deserved. He gave the poet a prize for his poem. He also gave him an extra 100 gold coins for exposing the greed of the guards. What was the clever idea of the poet which the king appreciated so much? Answer: without getting lashes, he shows greediness of the guards. This clever idea of the poet was appreciated so much by the king.